kind of colors. Alright, so we're going to start off, and all around you there's these different kinds of waves. They're traveling through the air, they're traveling through the wall, through you, and these are called electromagnetic waves. And these different waves have different energies, and depending on the energy, you can see it or you can't see it. So if you have too much energy, you can't see that. If there's too little energy, you can't see those. So, for example, have any of you guys broken your bone before? So, you did? What did you break? Your tibia. Okay, did you get an x-ray when you did that? Did you see the waves like going through you at all? No, because it has too much energy for you to see. So the waves were going through you to create the image that your doctor was looking at, but you couldn't actually see the actual waves. So that had too much energy. For something that has too little energy, it would be like radio waves. So you're driving in your car, and you're listening to the radio. There's a station miles away that's sending waves to your radio so you can hear it. But you don't see the waves coming into your car at all because there's too little energy for you to actually see it. But the energy spectrum that you can see is called your visible spectrum. And those are like the colors, the rainbow colors that you can see. So depending on what color you're looking at, the colors that you see are based on how much energy that wave has. So if you're looking at red has only a little bit of energy. So if you're looking at it, the wave, the little energy, your eyes are saying, okay, there's a little bit of energy, it must be red. Whereas blue, if you're looking at that, there's more energy in blue. So it's like, okay, there's more energy, it must be blue. So when you have the two, when you have red and blue, your eyes are reading the two different kinds of energies of the waves, and they're saying, okay, we have another color. So it's kind of like an orchestra. Do you guys, any of you guys play an instrument? What do you play? Saxophone? Alright, so if you're playing saxophone by yourself, you can recognize it as a saxophone. Anybody else play? What do you play? Clarinet. So when you're playing a clarinet by yourself, you can easily recognize it as a clarinet. But if you're playing your saxophone and your clarinet at the same time, you get a different sound. It's not your saxophone, it's not your clarinet, it's some new result. So that's kind of how mixing colors happens. So, but then there's a difference between mixing pigments, like your paints and your markers, versus mixing light, like those light bulbs back there. When you're mixing your red and your blue light bulb, you're going to get different than when you're mixing red and blue markers. And this is due to how your eyes are set. So you have little things in your eyes called rods and cones. When you're looking at pigment, like your paints and stuff, it's only your rods and cones. And then when you're looking at light, rods and cones. So it's like two different sensors taking in information and interpreting it differently. So you're getting two different results. So it's like, back to the orchestra idea. If you're playing the saxophone and the clarinet at the same time, you get one result. If you're playing saxophone and clarinet and your mom's vacuuming in the background, you're going to hear something different than the other time. You're getting two different results based on what you're saying.
Alright, she's right. There are no black colored pencils and crayons.
When you see the black
So
dot,
who can tell
when
me
your
what
eyes are
three
moving,
primary
you
colors
get that blurry image, so you're not actually seeing what's there, you're seeing what your brain thinks should be there. And because of the dark squares, you think the circle should be dark too. But if you look at just one dot and you don't move your eyes, you'll see all the other black dots fade away, and you'll
Close.
they're all white.
So actually, if you see this circle here, the three primary colors for pigment are cyan, which is like a bluish green, magenta, which is like reddish blue, and then you have your yellow. So when you combine your primary colors, you get your secondary colors for pigment, which are your blue, your red, and your green. So, like you were saying before, when you see this color, your eye will perceive this and like, okay, this is this color. So you see red. This is red. And scientists, they call this subtractive mixing. I mean, it's basically, like you said, it's just how your eye perceives the light. So now, so say you're drawing a picture. You start off with just a white sheet of paper. So this is pigment with no color. It's just a white sheet of paper. But say you start drawing, you start mixing your colors together a little bit, and it gets a little darker. You start to get closer to black. So this is when you mix, as you see, when you mix all of your colors and pigment together, you start to get black. So to show you guys this, we have a little demo for you right now.
You guys each get one when you see them.